Very fine. Good morning to everyone. I'm Mauli from National Institute of Technology, Agartala. I'm currently pursuing my integrated masters in chemistry. Today, I'm here to discuss a topic is electrophilic substitution. Is a very fundamental thing for organic chemistry. And today, in this top to understand this topic, we should have a basic understanding knowledge on aromatic. What is an aromatic compound, and what is an electrophile, and what is a nucleophile. To understand this, let us have a brief introduction about what is an aromaticity. Aromaticity is a compound can be called it as an aromatic compound when it following the features like when it's have a planar structure. The first one is planar structure, a compound or a molecule which is having a planar structure, and it should have a delocalized pi electrons and delocalized pi electrons. Delocalized pi electrons means the always moves inside the ring. A cyclic structure है ना, so inside the ring the electrons will revolves around the ring. So they are called delocalized, not localized. They are delocalized pi electrons. They are pi, not sigma. So and third one it's very important, and that is 4n plus 2 pi electrons. It should be there, and this is called as Huckel's rule. And this when it follows these three rules, and its compound can call it as an aromatic compound. So for example, let us see a basic example, that is a benzene ring. A benzene ring, let us see, a benzene is a planar structure. Yes, it is a planar, and it have a delocalized pi electrons. Yes, it has a delocalized pi electrons in the three double bonds, and the equivalent structure for this I let me draw. And this is the equivalent structure. These are the delocalized pi electrons, and here the Huckel's rule is saying and 4n plus 2 pi electrons should be presented, where n is represents number of rings. So number of rings here in the benzene is a single ring, so it should be 4 into 1 plus 2, so that is equals to 6 pi electrons. Yes, obviously there are 6 pi electrons, so it is an aromatic compound. And let us see another example, that is minus containing compound, negative charge containing compound. So this is also containing, like this is a single ring, a planar structure, and it has a delocalized pi electrons. Is a negative charge means it's have a excess of electrons, they are pair of electrons, so this is also having a delocalized pi electrons, and it is following the 4n plus 2 pi is a electron. This is a single ring, so it is 4 into 1 plus 2, it is a 6 pi electrons are there. So this is the basic introduction of what is an aromaticity and how we can judge it as a uh, aromatic compound or aromatic components. And let us see a brief introduction about what is an electrophile and what is a nucleophile. Electrophile is nothing but it can nothing but an electron deficient species, and it is represented with E plus representation, and nucleus is Nu minus, and it is a nucleophile, where these Nu minus is an electron donating species, and E plus is a electron accepting species. And let us see how these electrophile will attack on the aromatic ring. And we have seen here the benzene itself, it is an aromatic compound, and let us see how it will attack on it. Let us see basic examples of electrophile is nothing but NO2 plus, for example. Let us see, this is the example, and let us see how this nitro group will attack on the aromatic ring. See, if it is attacking on benzene ring, that is called nitration. That is called nitration. And when it is nitration, definition is nothing but when the sulfuric acid and nitric acid mixed together and heated up with benzene ring, it gives nitrobenzene, that is nitration. And what are the chemicals that we are using here? A concentrated HNO3, concentrated, not dilute one, concentrated HNO3 plus concentrated H2SO4, and these are under heating conditions around 333 Kelvin. It gives a benzene structure to a nitrobenzene, and this is the reaction. And let us see a brief introduction and detailed step pathway for the reactions, and that is we call reaction mechanism. A reaction mechanism is what? A reaction mechanism is a detailed step pathway from conversion of reactants to, these are reactants to products. And let us see. So here the reagents which we are using are HSO4, H2SO4, that I'll write like this, HSO4 and single bond H and plus. And even this is the first step, and that is nothing but generation of electrophile, and this is the first step in this reaction. So this is HNO3, H double bond O, and not double bond, and this is O2, and it oxygen will actually oxygen containing a lone pair of electrons, so it's, even it is a nitric acid, it will act as a base. What is the role of a base in a reaction? Means a base always abstract a proton. So here a base will abstract proton from sulfuric acid, so it will forms a compound like HSO4 minus plus HO and H, a positive charge on the oxygen as well, and this is NO2. So here it will, positive charge will be satisfied by transferring these electrons, these bonded electrons to on oxygen atom. So as a result of this we will get H2O plus NO2 plus H2O, a water molecule, and NO2, a nitrogen electrophile, that is an electrophile that we are get here. So after this we will have this nitro group will attack on the benzene ring. It will attack on benzene ring. Let us see how it will attack. This is a benzene ring. So this benzene will attack by the nitro group, NO2 plus. So the pi electrons which are present, that will attack on this one. So as a result of that we will get a intermediate compound like this, a benzene containing NO2, and let's have this hydrogens as well, and this is an hydrogen, and as well as a carbocation will takes place. So here I would like to mention the second point, formation of carbocation. Formation of carbocation, the first step is generation of electrophile, that is happening between the reagents, and after that it is happening formation of carbocation. That carbocation is on benzene ring, so this step is focused on the formation of a carbocation. And after the formation of carbocation, this proton, the third step is proton removal, and this proton removal takes place after the formation of carbocation. So the removal of carbocation is like when a proton will be removable, when it has a base, like already in the reaction itself we have HSO4 minus, and it is actually, it's formed from the acid H2SO4, it is an acid, but after removal of H plus from the H2SO4, it forms H2SO4 minus, where minus represents the basicity, that means Lewis base, that is electron donating capability, that is here we got. So here after further reaction the proton will abstracted from the carbocation compound, so it will take this hydrogen, so it will form a compound like this. So here whatever the hydrogen is left as a H plus, the bond will shift to satisfy the positive charge, so it again forms a double bond. So a double bond is formed and a nitro group is there. So finally what we get, a nitrobenzene we got. And as like we see, we have taken nitro as our electrophile, so that's why we got nitrobenzene. If we take SO3, then it is a sulfonation, so it is a sulfur trioxide, so it is sulfonation. And if we take some other like a acyl group, then it is acylation. Some it is like a Cl2, if we take it is an halogen, so it is a halogenation. And like anything that like electrophile could be a halogen or acyl group or a alkyl group. So we will study these things, alkylation, acylation, and all these things. So here the basic example is like an electrophile will substituted on the benzene ring.